Another day, another video. Question is, what are we gonna talk about today? What about Pinocchio? Yeah, I kind of feel like Pinocchio today. I also kind of look like it. I don't know why, like is it the nose? Let's do Pinocchio. Hello and welcome to another Solana tutorial. Today, we're gonna talk about Pinocchio. Again, we kind of talked about that already once when I did that programming challenge, but there I just basically mentioned it on the side and I was like, yeah, I'm gonna use Pinocchio. And then I talked a little bit about it. But today, I think Pinocchio deserves another deep dive. And also, not just Pinocchio, but like a specific aspect of it, which is the no standard entry point. Because I keep reading about no standard and I have no idea what that even means, and that frustrates me a bit, or at least it gets me curious to what the hell is that. I want to know, I want to understand what is a standard entry point. Probably the entry point that I use as a standard on Rust, but really I don't know. In the previous video we actually had a look at the new version of the Solana Rust SDK. And we figured out that when we use the individual crates, we can have fewer dependencies and therefore quicker compile times. And so Pinocchio fits well with this because Pinocchio, the whole point of that is to have zero dependencies. So there's no other dependency than Pinocchio itself. All of it is in Pinocchio, which allows you to, build smaller programs. With the disadvantage that you need to know more about Solana programming and the programming model and which security checks you actually need, compared to, say, Anchor, where most of the security checks are actually done behind the scenes and you don't need to worry about them. With Pinocchio, you really need to know what you're doing. But for some high-level devs, like we are trying to be here, right? This might be the thing that you want to use because you might want to be super efficient and have small program sizes and as little compute as possible. That's basically the outline of why you want to use Pinocchio. But then there's like caveats and things and stuff that I don't understand yet, like this no standard entry point. So why not make another video learning about it? Potentially doing a little bit more vibe research. But the good thing is, when I do the vibe research, is that I will double check what I read there. And I will, kind of fact check and try it out and see if that's actually true. Because you should not believe what a chatbot tells you. You should also not believe what you read on the internet. Anyway, so let's get started. We're looking at Pinocchio. So, Pinocchio now lives in answer XYZ, which means that's an official thing. Like, it doesn't get much more official than that, because they are the former Solana Labs people. So, when it comes to Solana, I trust them. I wouldn't trust them with everything. I don't know, for instance, aviation technologies, I wouldn't trust Answer. But when it comes to Solana and Solana development, you can totally trust Answer. Okay. With that established, let's look at Pinocchio. It's still active, yesterday they're pushing stuff. What did we learn? Still don't know how to get there without typing this. Pinocchio is now in version 0.84, which is the latest. Improved fallback for no standard. Here we have it again. What the hell is no standard? Oh yeah, he's the original. This test generally depend on standard and therefore conflict when following. I mean, I can read this, but I understand fairly little because I don't yet comprehend what is no standard and standard. Standard library, I mean, it kind of sounds like something like a Rust standard library or the C standard library that's like, My goal for today is understanding what this means. What else do we need to know about this? I mean, we looked at this already. The TLDR is that it's a replacement for Solana program, which we had a look at yesterday, whereas we use it to write on-chain programs, and it's optimized both for compute and binary size. So smaller programs and fewer compute units used in the execution. The library defines a program entry point, the core data types, some logging macros, syscalls, sysvars, and CPIs. Zero dependencies and no standard crate. What's the no standard crate? Efficient entry point macro with no copies or allocations. So again, efficient, not always super secure. There's a trade-off, but you gotta know what you gotta do or what you want really. And improved CU consumption of cross-program invocations. That's also very helpful. In which program did we do the CPIs where it costs so much to do a single CPI? I think that was with Anchor. Of course it's with Anchor, because Anchor is like pretty much the opposite of Pinocchio. Same language, but each of them have a different focus, really. And the Solana program crate, you know, this one, that's somewhere in the middle, if it was one-dimensional, which it isn't. Okay, defining the program entry point. We had a look at this. But this stuff is also kind of new to me. Like, I've never read that before. Because here it comes again, this no standard panic handler. So, Solana needs to define an entry point, which will be called by the runtime to begin the program execution. Yes, so when we have a binary, because that's basically what we upload to the on-chain data account, a program data account, and that data is then used for executing the program, the runtime will need to know, well, where do I start? Where in this binary, where in this bunch of bytes do I need to start execution? Which of those bytes are actually, you know, runnable code? And that's why we need that entry point. That's basically where we say this. We looked at that in the entry point video that you can find here, how that's defined. If you do it in C, you just define the function like that. And in Rust, you basically have to export that function name, extern C entry point, something, if I remember correctly. But the entry point macro does that for you. The entry point macro emits the common boilerplate to set up the program entry point. The macro will also set up, and this is new to me, the global allocator, the custom panic hook, and the default allocator. Oh, and the default panic handler. What are all these things? The entry point is a convenience macro that invokes 3 other macros to set all symbols required for program execution. So entry point defines this, this, and this. Program entry point is pretty clear. Clears the program entry point, you know, this extern C, blah, blah, blah. Default allocator declares the default global allocator. Default panic handler declares the default panic handler. I guess, I mean, from the name, if we raise an error, like if there's a panic, we raise an error that is never caught, so it ends up in a panic, or we manually panic for some reason, then somehow the program will need to know what it's got to do. And so for that, we also need to define something. And I guess the default panic handler declares that default panic handling. If all dependencies are no standard, you should append no standard panic handler to declare a Rust runtime panic handler. There's no need to do this if any dependency is standard, since Rust compiler will emit standard panic handler. So standard seems to be something Rust compiler-ish. So no standard might be we do it all ourselves. I have no idea, still no idea. But the usage, pretty much the same as you know from Solana program. Pinocchio will also export pubkey and stuff like that. However, this is something different than the Solana program pubkey or the Solana pubkey crate. It's a different implementation. This is pure Rust. The other thing might also be pure Rust, but overall they have more dependencies on things. It's a different implementation, so it's a different thing. It's not the same. You might need to work with this differently, even though it has the same name. So this can get confusing if you're a beginner dev especially, and once you work with Pinocchio and once you work with the Solana program crate, different things. Very different. Well, probably not very different because they represent the same thing, but you know, it's different types. Not compatible. Pinocchio also offers variations of the program entry point, like the lazy program allocator and global allocator, like the no allocator. In order to use these, the program needs to specify the program entry point, global allocator, and panic handler individually, because the entry point is equivalent to using all of those, the default, and program entry point. So if you write this, it's really this. But if we want something else, like the lazy program allocator or the no allocator, then we gotta say, instead of this, lazy, and instead of this, no allocator. Any of these can be replaced by other implementations. And we also already had a look at this in the previous Pinocchio video, the lazy entry point, where the normal entry point is what we are used to from Solana program. It parses everything, like the entire instruction data, accounts, program ID, and gives you that neatly here. But then in some cases, it is beneficial for a program to have more control when the input parsing is happening, or whether it's even needed at all. So there's this lazy program entry point. Only wraps the program input and we can parse it on demand. Mainly we want to use this for small programs because it gets more complicated for bigger ones, because the more instructions you have, the more, you know, complex the manual parsing. Because for some instruction you do want to parse it, and for some you might not want to parse it. So yeah, it can get a bit complex. But yeah, if you know you have a very small program, like one that is just used for, I don't know, logging or I don't know what, then the lazy program entry point might be what you want to use. Okay, and to use it, here we go. We just replace it with lazy entry point, but then we need to put those manually as well. Okay, so Pinocchio changed since I last looked at it, because that is new to me. And here you see, if we do the lazy entry point, then we just get the context, the instruction context. We don't get it parsed in program ID, accounts, and input, because, well, basically this is just a pointer pointing to where all that information lives, but it's not parsed yet, so we didn't waste any compute on actually reading it, because we might not want to read it. And then we have functions on that where we can get that, but that will then parse it. And here's once again that note that the lazy entry point does not set up a global allocator nor a panic handler, so we should explicitly use the provided ones. When writing programs, it can be useful to make sure the program does not attempt to make any allocations. For these cases, grammar error. Pinocchio includes a no allocator macro that sets a global allocator just panics. Ooh, this is not English. That sets a global allocator that just panics at any attempt to allocate memory. To use the no allocator macro, use the following in your definitions. Let me guess, the no allocator here instead of this default allocator. Okay, good. Can also be used in combination with the lazy entry point. Create features, standard. Here we get to the thing. Finally, we get to the thing that I'm really interested in. However, I also kind of want to look at those things. But let's at least understand what this means. We came so far, let's not stop here. Per default, Pinocchio is a no standard crate. What does that mean? This means, oh great, that it does not use any code from the standard library. Rust? The Rust standard library is the foundation of portable Rust software. Sets a minimal and battle-tested shared abstractions for broader Rust ecosystem. Offers core type like vector, option. Okay, so the things we like to work with, you know, vectors and options and other IO stuff, multi-threading, you know, multi-threading is for sure thrown out of there for our purposes because we can't even do that on chain. Standard macros, primitive types. Okay, hold on. Primitive types are also part of the standard? Even the U64 is part of the standard library. If we're not using that, either we need to have our own implementation of that or we can't use them. I mean, that's part of the standard library then? I mean, it kind of seems to me that that's the core Rust stuff. I mean, I get how, you know, the implementations for vector and option and stuff you might want to throw out, but the primitive stuff that is like part of the language itself, I would say. I mean, not quite sure how you work with no standard then. But well, Pinocchio is a no standard crate. While this does not affect how Pinocchio is used, there is one particular apparent difference. In a no-standard environment, the message macro does not provide any formatting options since format requires the standard library. So yeah, that a format macro is part of the standard library makes sense to me. But we will still have access to true, false, while, and those sort of things. So I don't fully understand it yet, but I'm getting closer. In order to use message with formatting, the standard feature should be enabled when adding Pinocchio as a dependency. So it has a feature, standard. Then it does use the standard library. Instead of enabling the standard feature to be able to format log messages, it is recommended to use Pinocchio log crate. Provides a lightweight log macro with better compute units consumption than the standard format macro. Format macro uses quite a lot of compute and requires the standard library, which is probably why it uses a lot of compute. Maybe. Who knows? Program, entry point, global allocator, and default panic handler can only be defined once globally. The program crate is also intended to be used as a library. It is common practice to define a cargo feature in your program to conditionally enable the module that includes the entry point macro invocation. The convention is to name this feature BPF entry point. Hold on. Is this basically the opposite of what we gotta do with for instance, the SBL token library, where we use the feature no entry point? Probably. So basically what's happening is when we define our entry point, we define those three things. The program entry point, global allocator, as we saw it here. Boom, those three. But they can only be defined once. And then you get an issue if you define them twice. Should we look at that like really in code and stuff? I want to do it like, I'll start coding in a second. I mean, I'm almost done scrolling through those docs here anyway. But, oh, so many things to explore. I love this. This is so many learning opportunities here for us. So basically, if we do that, we define the program entry point and the two others. And all of them can only be defined once. So if you write the program that should use this other program as a library, like we use the SBL token as a library. SBL token is its own program, but some of those modules we might want to use for, creating those instructions and whatever. And if we would just import it, then it would redefine the entry point, and then we would get a problem because we can't define the entry point twice. So what you do is you set this entire thing as a module with a feature, and you name it this, BPF entry point. So if we import that library with that feature, only then will it set the entry point. But if we don't specify that feature, then this thing is not imported. CFG expressions can be used to conditionally include code to support a requested feature at compile time. If I say feature standard, then I have to compile the Pinocchio package again with that feature, because then at the compilation stage, it will add all of the code that, has the feature. That makes sense. Okay, we're learning stuff about Rust. I like it. The library in this repository is based on or includes code of the Solana SDK and the Solana no standard entry point. Oh, Caveman Loverboy. Solana no standard entry point. Oh, we looked at that. We looked at that when we looked at different entry points. But, you can use the U64 and U8s. But I guess, hold on. So the standard library probably just has functions for those. The primitive types will still exist, but then this thing, maybe the min and max values and stuff like that. So many things that we can look at. What am I most interested in? Let's start with a no standard, and then later maybe still look at this entry point configuration with that feature. Okay, let's start coding. Let's actually get our hands dirty. I mean, figuratively speaking. So this is the entry point from Solana program entry point that we used last time. Today, we're gonna use Pinocchio. Let's first do a no standard Pinocchio program, just so we understand that difference, because that's what we're here for. Add Pinocchio in 0.84. Perfect, so that's the newest version. And in its simplest form, this is the simplest Pinocchio program that you can build even without using a message like this. I mean, it does go simpler because you can use the lazy entry point, but this is comparable to the program we had in the previous video. It just says okay. It parses the input parameters and then just says okay anyway. So that's a prime example for you could use the lazy entry point instead. But anyway, this should compile. Cargo build SPF. There we go. It just has this one dependency to Pinocchio and is compiled in roughly half a second, which again, faster than with the Solana SDK, Solana program crate, where it took me like 1.5 seconds. Compile time also matters sometimes. Although if I recompile it now, it's done in 0.7 seconds because I don't need to recompile the whole Pinocchio thing anymore. So at that point, it doesn't really make a difference. But it does make a difference in terms of program size. So if we check, this thing has only 1.5 kilobytes compared to, here, that's what we had previous video, the 17.2. So that's the previous one, and that's what we have now. Pretty much of a difference. And it's exactly the point why we want to use Pinocchio, smaller binary size, fewer compute units usage, less compute usage. Can you count them? Yes, you can. So yeah, however, it comes at the cost of, less checks and shit. Here, this really comes at the cost of we can't use as much because those things are super lightweight and we don't even use the standard library. I mean, probably part of why the other binary is big is because it uses the standard library. So what can we now not do that we could with the standard library? Let's try and figure this out. So this U8, for instance, we can use U8s. And we even have a bunch of stuff from here, from bytes, from whatever. Do we have a vector? But this comes from alloc vector. This is not standard, this is alloc. But yeah, all of a sudden we now have 4 kilobytes, because guess what? I guess we're now using that. So I don't yet fully understand what is part of standard and what is not. But if we don't do that and we build, we get down to 1.5 kilobytes again. Let's just experiment and be like, okay, let's use the feature standard. Then if I rebuild, then it will need to build Pinocchio again as well. There we go. Because it now has to build it with that feature, the non-standard. Wait, that's my, this is my program. I should maybe call it something. But now I use the feature standard. Let's call it my Pinocchio. Okay, build. There you go. Builds my Pinocchio. Use better names for your programs to not confuse yourself. Good. If we compile it with standard, oh, guess what? Look, we're getting closer to the 17K that we needed in the other one. Now we have 14K. So yeah, most of that probably is because we include the standard library or parts of the standard library. Which parts do we include? Do I know that? No. My program looks the exact same, but suddenly, boom, it needs more binary size. Like, it needs to put more stuff into my binary because I include another library. But what can I do now with this that I couldn't do before? Wait, if I now do the same vector thing, how big is it then? It also grows a bit to 15, so it needs to include yet another thing. But yeah, I don't think that that's really part of that. What can I do now that I couldn't do before? Ah, there we go. This uses standard format. So there I have the explicit import for that extern crate standard, the Rust standard library. These models are the bedrock upon which all Rust is forged. Implicit methods on primary types are documented here, but primary types obviously are part of the language and not part of the standard library, right? This can be a source of confusion for 2 reasons. While primary types are implemented by the compiler, there we go, the standard library implements methods directly on the primitive types. Yeah, I think I got that right. I made that assumption earlier. And it is the only library that does so. Standard library exports many modules with the same name as primary types. These define additional items related to the primary type, not the all-important methods. For example, the primitive type i32, the list of the methods that can be called on the 32-bit integers. And there is a page for the module that documents the constant values and so on. Technically, not all the standard macros are defined by the standard library, some are defined by the compiler. So we have everything that the compiler defines, because that's Rust. But what the standard library defines, we need to import. Okay, so to once again dig into this a bit more, there's a page for the primitive type and there's a page for the module. So the primitive type, this is what we always have, I guess, then. All of those we should have also without the standard library, because that's the primitive i32. All of that. But the standard, the module, standard i32, deprecating all constants in this module replaced by associated constant on i32. So basically they're saying i32 is not anymore in the standard library because basically everything is now owned by the compiler anyway. So it's all on the primitive type anyway. We don't, the max and min, the constants that used to be part of standard are now also like here since 1.34. Yeah, okay, good. So, I mean, okay, that makes sense. That makes sense. Probably same with primitive U8, the min at max. We have those and all those functions that I saw here. Standard U8. And the same thing with the U8 here. That has also been deprecated. Okay, so the primitive types are not actually really part of standard anymore. How about the vector? Vector, so standard vector, implementations with capacity, try with capacity from raw parts into raw parts. That's in standard alloc. Haha. This is in standard vec. Reserve, for instance, reserves capacity for at least additional more elements. So could I do vec reserve? Yes, I could. Reserve an additional 100 elements. But that's also in alloc vec. What about... So I still don't get if this is part of standard. Let's vibe research. What is vec and where does it live? Vector is built on top of alloc vector. And that's the thing that I'm actually importing, which is available in environments where only the alloc crate is used, e.g. embedded or non-standard targets. Here we are getting exactly to where I am confused. Okay, so the standard vec is the alloc vec plus a bit more. There we go, alloc, which seems to be another crate that we can use, which, you know, looks pretty much the same. If I look at that, the alloc vec, that, you know, that's literally, yeah, that's literally the same docs. Vec is so not in the standard library. I mean, also in the standard library, basically re-exported and added a few features, but we can use the primitive types and the vector also on non-standard. Okay, fine. So I still didn't find useful things to use in the standard library that I do not have with a non-standard. You know what we're gonna do? We're gonna cd here and we're gonna recursively copy the no standard to standard. And then we have a standard with the same thing. This is how we, you know, with the standard, this is how we would build it. But then in the non-standard, I'm gonna remove the feature again. And now it's down to 1.5 kilobytes here. So standard versus non-standard. Let's compare. As we have said, one of the convenient things that we have in the standard library is the format. We can format or use the message macro. Supports simple strings as well as Rust format strings. When passed something other than an expression, the tokens will be passed through the format macro. So this under the hood will then use the format, and that's why we will need the standard library. So if we do stuff like, look, it's a number, this will work. We'll just build. However, if I do the same thing, I mean, even here it still thinks I can use format. Oh, that's in alloc again. See formatting syntax documented in standard format for details. Stable alloc standard format. I'm confused again what is part of standard and what is not. Leftover tokens. Aha! But here, hold on, maybe it's still, I mean, aha, but look at that. Support simple strings of type string. Expression will be passed to SOC, typically logged for static logging. Look at that. Even the docs are different in here. If I import this message, even though it's the same use Pinocchio message, different docs to here where it says the same thing, but then more. Same thing, but then more. Whereas here, just this. That's fun. Why? Because there's this nice feature that requires the standard library for that to work. I can only do that. It's just a simple string and it will just log a simple string, literally writing those brackets or braces, curly thingies. That's cool. See, and I had that issue before where I was like, what? Why can the Pinocchio message not do that so neatly? Well, yeah, because it doesn't import the format if it doesn't use the standard, which per default it doesn't. You need to say that explicitly that you want that. But if you do that, then your target is, you know, bigger because it uses the standard libraries compared to, you know, this. So what would I need to do to fix this? Also read that somewhere. It's recommended to use the Pinocchio log crate. Okay, so here we could say cargo add Pinocchio log. Oh, well, that has some dependencies. So that's not zero dependency anymore, just saying, but it's okay. And then how do we use this? This has a log from Pinocchio log. And here I can probably say stuff like that. Pinocchio log. There we go. So we need to import this and then we log. Look, this is a number and this can be formatted again like that. And if we build that, how much bigger is that gonna get now with all of those dependencies? Still under 2 kilobytes. Still just 1.9. which definitely better than my almost 15 here. And also it's more compute efficient. And that's what's even more important than the program size in my eyes. For the program size, yeah, you pay a little bit more rent, but it's the compute that really makes a difference. So this is probably what you want to do for logging and not import the standard library. And I haven't found like other reasons why you really want to include the standard library. Pinocchio itself is non-standard, and I now understand what that means. Isn't that great? And all of that got started with a no standard entry point from Caveman Loverboy. But even that already uses the no allocator. So even there was already split. Should we also have a look at that? There's so much we can still have a look at. Yeah, let's continue a bit looking at those things. So instead of defining this entry point, I can say use all of those. I need to import all of those. But that should also do, yeah, there we go. And that should do the same thing. But what if I wouldn't have those two? Would it then not compile or just not run the program? I think it would just not run the program, yeah. But I would be interested what that actually looks like then. So I guess we gotta once again deploy a program. 2 transactions, there we go. It's a small program. Okay, so we can deploy this program, and just to double check that this is also working, let's run it. Cool, so that worked. Just calling the program. Look, it's a number. It is a number, indeed. Nice, so we can execute that program, no problem. Fine, looking back to here. What if I wouldn't have a panic allocator, for instance? Build this, building works, and I deploy this. You think it lets me deploy, or does it already complain here? I mean, I can create the transactions to write the buffer account, that will definitely work, but then will the final transaction to actually deploy it also work? This one? Yes. Okay, then running it also works. As long as we're not having any panics, I guess we're fine not having a panic handler, right? Okay, we don't have a panic handler. Should we keep digging? Nope, we're first gonna steal the default allocator as well. We rebuild, we redeploy. And here we have no standard. If all dependencies are no standard, you should append no standard panic handler. There's no need to do this if any dependency is standard, since the compiler will emit. But I don't think any of mine is standard. So now I don't have any anyway. So let's run this. That also still works with just 138 compute units. Yeah, that's an efficient log. I like it. So why do I need those again? It seems to be working without. So why do I need those? Well, let's panic. Panic at the disco. That's standard though. It's a standard macro, which will make this whole thing standard again. And if I use standard, then I will get a standard default panic handler. If I just build this, unreachable expression, yeah, I'm fine. Suddenly, wow, yeah, we're up to 7 kilobytes. Panic, I guess, brings part of the standard library with it. And that probably also brings a panic handler with it. Let's try. Let's deploy. Ooh, there we go. So we only need a custom we only need a panic handler if we have a panic. And let's check that compile time. Look at this. It tells me ELF error, unresolved symbol, custom panic. Add instruction. So we can't do a custom panic if we don't do a panic handler. So we will either need this default panic handler or a no standard panic handler, like this one that we get from Pinocchio. With this one, duplicate, found duplicate item is first defined in crate standard, which non-standard depends on. What? Since when did we now depend on that crate? I told you specifically not to. Oh wait, no, that's mine. The non-standard Pinocchio there, yeah, that depends on it. This one depends on it. Why? Because of that thing. Because of my panic at the disco, which uses some standard stuff. Okay, so we can't do a no standard panic handler if we use a standard library, I guess. So I guess to fix that, we gotta use the default panic handler here. Would that compile? That would at least compile. And would that also deploy? Yes, it would. And guess what that's doing? If a panic occurs, then this default panic handler probably will make it so that the program result is a program error of some, I don't know, I guess custom program error, whatever. Let's see by running this. Yep, there we go. Panicked. So it seems like what it's doing is it logs where the error occurred, which file. It says panicked and then failed SBF program panicked. Wait, but what's the actual error then? Then we get, so that's an instruction error. Can I get more details on that instruction error? If we have an error, can you log that error? So the error is program failed to complete, which is a separate instruction error. Instruction 0 failed to complete. Cool. So if it panics, it fails to complete, which is its own error. But to get there, we somehow need to have this panic handler defined. And we can use, you know, our own panic handler. We can even have a look what that actually does. It defines this custom panic, which if there is a location, then it logs with sol log the location. See, that's what we saw here. And then it also says panicked. That's what we see here. That's the implementation of it, of our default panic handler. No standard panic handler. That's how you can do a not. Like if not features and so on. That's how they then do it with a no entry point. But yeah, the no standard panic handler for no standard. If we use Solana, panic handler, unsafe, just some logging file column and then panicked. So seems pretty similar. When all crates are non-standard and the standard feature is disabled. So I'm learning a lot about standard and non-standard today. So that's cool. That was exactly the goal. So nice. All of the crates need to be non-standard. So everything that I import or, you know, use up here needs to be non-standard. That's why non-standard is a common term in Rust or in Rust development. A library is non-standard if it doesn't include anything from the standard library. With this, we're not non-standard because I am now also using something from standard. But just to panic, there's probably another way how I could, you know, panic without that panic macro. But I basically just wanted to get there. So if I don't panic, I can again use the non-standard panic handler, I would assume. So let's check. Can I? No, I cannot. First definition in standard loaded from this error originates in a macro non-standard panic handler. Okay, so it's not just that. First defined in standard. Yeah, why is it, why? I mean, the lib standard will depend on standard, but why do I depend on that? Vibe code. Unless you explicitly opt out, Rust uses standard library per default. To disable, you must use no standard at the top of your crate's main source file. Ha! Learning something. Vibe coding. Vibe research, I tell you. I mean, first you think it's hallucinating, then you try, and then you make your own top of my crate's main source file. So I need to say I am no standard. That does not fix things. Wait, but I got a different error though. Hold on. No global memory allocator found, but one is required. Hehe. Aha! So the global memory allocator probably, like this one, the default allocator, now it even complains about this. Probably if I were to drag in the standard library, then it would use some standard allocator. Let's see if I use this default allocator here. Default global allocator. Then it should not complain about this. Yes! Vibe research. Oh, that's the way to go. Thank you. Chatbots are not stupid. At least not completely. Okay, cool. So now I learned something again. I now know what that does. It avoids dragging in the standard library if I tell it to, because Rust will otherwise just include the standard library anyway. And then I build it. Can I now deploy this? Yeah, and I can probably also run it, but it also doesn't do anything specific. I don't know. Is there another? Oh, it does what? Oh, I think I see my problem. I cleaned it. If I clean it, I have a different program ID. Oh, that's my problem. I'm sorry. Yeah, okay. So that's, yeah. Fun fact, if you cargo clean, you also delete the program public key. Like the key file, the key pair that's in there. And then it creates a new one, so you have a new key here as well. So, okay, but that explains why it still gives me the error. Okay, now it shouldn't. right? Okay, good. Good. It's another number now, and that works. 140. Cool. I mean, so far so good. We learned about standard and no standard. We're no standard now. If we use the default panic handler, would that change anything then though? Wait, what's right here now? Panic handler function required, but not found. Interesting. So the default panic handler, even if we do that, this macro accepts a default panic hook that logs the file where the panic occurred. What about standard? This is used when the standard feature is disabled, but either the program or any of its dependencies are not no standard. Okay, so if we are no standard, we gotta use this one. The default one will not work because it requires this panic handler but not found. But like this, it will build. Okay, cool. Good to know. So we understand when we need to use what. The default also for no standard, but when we are ourselves using standard. And the default allocator, is there also a no standard? Wait, let's see what default allocator actually does. Sets up default global allocator that uses a bump allocator to allocate memory. And if we do not need to allocate memory, hold on, how big are we? 1.7? We can use the no allocator that does not dynamically allocate memory. It's so fun. Yeah, that digs into like heap. For the heap, you need an allocator to allocate the memory, right? Because the heap basically is just a bunch of storage, and then you need to somehow manage where you put what and everything. And if you don't allocate anything, you don't need an implementation for that. That's a global allocator that denies all dynamic allocations. This is useful when the program does not need to dynamically allocate and manages all of their own resources. The program will panic when it tries to dynamically allocate. There we go. So that's, and for that we need the panic handler as well then. So this is used when the standard feature is disabled. Okay, because let me guess, when we have standard, then standard will bring some allocator with it. Okay, but that's just a guess again. Let's do no allocator and the no standard panic handler. We are so no standard. It's amazing. And we don't need to allocate anything here. That's fine. With a no allocator, does that still build? It does. Does it make my program smaller? It does not, but that's okay. Let's deploy this. It's a number again. That works. But what if I would allocate something now? What do you usually allocate? What do you usually put on the heap? Using smart pointers from the standard library, like box, that allocates this on the heap. Why use box? Well, I don't want to use the standard library. If you need more control or you're writing low level code, you can use vector. Is box directly in the standard library, or can I use box as well? I'm literally gonna allocate, I don't know, a byte, lol. Let something be allocated. Box. Fail to resolve. Use of undeclared type box. Hold on though. But we also don't have a vec anymore. Nope, we also don't have no vec anymore. Because guess what? We are no standard, therefore we lost all of those things. Really? Shit. But that confuses me again then. Because I thought the alloc is not part of the standard and we can use that. But turns out, no we can't, because then we're once again part of standard library. Interesting. See, digging deeper is important because I had again a wrong assumption. Box and vec are in standard, right? Okay, more vibe coding. Often relying on the alloc crate. Use smart pointers like box and vec from alloc. Yeah, okay, but I can do this then. So I can use alloc because again, it is not part of standard. Okay, so I did get this right. This is so confusing, but also kind of fun. I say extend create alloc and then I use the alloc boxed box. Let's see. I say extend create alloc and then can you just, and then and then you are smart enough to import that from alloc boxed box. And I could do the same with vec as well. Vec, there we go. And now I could also use the vec from alloc, which is fair. I just need to here, that makes sense. I need to now say this because if I'm no standard, then I'm not automatically importing the standard library, which imports alloc, the Rust core allocation and collection library. Library operates smart pointers and collections. Normally doesn't need to be used directly since its content are re-exported in standard crate. That's what I'm saying. But crates that use the non-standard attributes, however, will typically not depend on standard. So they'd use this crate instead. Bam! There we have it. That's the explanation. Ha! Hehe! Nice! Okay, and then if we let something to be allocated, and maybe we should also use it just so it's not optimized away or something. It's a boxed number. And then I say something to be allocated. How can I get the data out of the box? Oh, deref. That's how you do it. Yeah, easy. You deref. Classic. We're working with pointers here. Yeah, that's exactly basics. Computer science basics, Andy. You learned this. If it's allocated, like it lives on the heap, and we have the pointer 2 there with this box, then we just deref to get the actual value out of this pointer. Hey, go there in the heap and get me that U8. Okay, it's a boxed number. And guess what? This ain't gonna work. It will build, and I will be able to deploy my program. 8 transactions now. Wow, it's getting bigger again. We got 7 kilobytes. And then if we run this, wow, we even get success. Are you kidding me? It's a boxed number. Oh, yes. Scroll up. I screwed myself. I mean, of course it's gonna work if we have the default allocator that uses a bump allocator. That's just a strategy how it handles the pointers in the heap, you know, how it, you know, whatever. That's not too important because you can have different strategies. But anyway, that would go too deep into computer science. But I wanted to use the no allocator. So, revert. Do that again, build that again, because guess what's gonna happen if we have no allocator and we try to allocate anyway? We're gonna die in line 23. Look at this. There you go. There you go. SBF program panicked in entry point even. It says it panics in the entry point mod RS. It doesn't panic here. Panics in the source entry point. Okay, fine. But really, this is the reason why it panics. So program failed to complete. We panicked. Why? Because we are allocating stuff even though we have no allocator. Or really the allocator, what it does. You can have the implementation of it here. Allocate memory as a bump allocator. I'm a bump allocator. I don't free. Nice. Yeah. Okay. But again, going to it is a pretty simple implementation of this. But my no allocator ensure that the offset does not overlap with previous allocations. Okay. So allocating unchecked and calculating offset I can do. But as soon as I try to actually normally allocate, like here with a normal alloc, then I guess this will fail. I don't see the code for that where that fails. The entry point 482. That's where we are. Source entry point, but 482 is here. Here we have an implementation of global alloc for this no allocator. An allocator that does not allocate memory. Deny all allocations, so I don't need to free. Nice. And if we have this alloc, this actual alloc, then we panic with a no allocator. Boom! That's cool. And that's what happens if I do a box. So I'm not allowed to do a box if I have no allocator. So I would need to let the number live on stack. And then I can use this. And if I really want to deref it, then I need to first get the pointer. This is so stupid. But it works. I could also, you know, not do that. Same. But because it's fun, it's a stacked number. I'm having way too much fun with this. I mean, don't know about you, but you know, I'm enjoying this way too much. See, that's why I'm a programmer, you know. Just having fun coding, okay? That's how you do it. If it's too serious, then it's boring. And also, just I mean, those messages just I don't need to free. I'm a bump allocator, I don't free. You only need to free if you run out of memory. And we just never run out of memory because the program will terminate sooner anyway. So anyway, yeah, if you call that now, that should work again. Look, that's a stacked number and it works even with a no allocator because we don't allocate. Bam. Okay, good. But I think that's good enough now. Yeah, I'm happy with what we learned about the allocators and penny candlers, and specifically dealing with standard and no standard. We have a much better understanding of that. I will leave for one of the next videos, possibly, a more deeper dive into, defining features like that. We have already looked at it a little bit today, but that I could, we could look into that some more. I'll put it on my list because that will help us really understand what the no entry point does. Or just real quick, as a spoiler, it's the same as if I do this. The entry point is defined multiple times. If I call that twice, right? We can't do that. Entry point must be defined only once. I'm very happy with what I learned today. I'm gonna call it. Hehe. Look at that. Why am I having so much fun today? I'll grab him by the nose. Sorry, what am I doing here? Finishing the video. Yeah. That's what I'm doing. Hold on. Oh, yeah. Okay. Yeah. So, that looks so ridiculous. I'm having way too much fun here. Me with my head. I'll have to end this video now. I don't know what's up with me. I was having way too much fun looking at Pinocchio and the no standard stuff. Not a lie. I didn't. My nose didn't grow. That I really had fun doing this. My nose is always that long. Fun times with Pinocchio. It must be a cool thing, right? If I'm getting excited about things, about the library and just enjoying myself to the fullest, then it must be a cool thing, right? So go look into Pinocchio, all the features that it has. Today we just specifically deep dived into, no standard and stuff. But the pure fact that Pinocchio is a dependency-less, no standard library is pretty cool. And you can write Solana programs with that without needing any other dependencies. It will make it a bit more difficult and you will need to do more security checks yourself. But for small programs, that might be exactly what you want to do. So yeah, check out Pinocchio. No lie, it's fun. Okay, good. Breathe, Andy. Yeah, it's fun. I enjoyed that. Bye.